Okay, good evening, everyone. So, I think now we will start the session for this week. So, I hope my screen is visible and voice is audible to everyone. Okay, uh, so firstly, I'll just introduce myself. I'm Adyasha Sahoo from Electrical Engineering Department, IIT Roorkee, and I'm the TA for this course Smart Grid Basics to Advanced Technology. And for this session, we'll be discussing the content for week 4. So this is how briefly we'll go through the session. We'll start with the overview of week 4, the content of the week 4 we'll discuss in brief. Then we'll have a question and answer session where we'll discuss some problems related to the topics that we discussed. Lastly, we'll go through any doubts if we all are having. So these are some links if you want to use. You can contact me over email, and the slides they are available in the Google Drive mentioned here. If someone is not able to attend the live session during these times, you can also access the video in the YouTube in the link given below. And if anyone wants to connect, the LinkedIn ID is also given. So this week, I think the course started with wide area monitoring systems. So firstly, we'll go to what is the definition that is given by the standard IEEE. So according to it, it is a collective technology that helps to monitor our power system in the real time. So we monitor the states of the power system in real time, and we identify the system stability related issues that are going in the real time using this data, and then we take the control actions so as to improve the stability of the system. So three components. Firstly, we'll measure or sense the system dynamics in real time. Then we'll communicate these states of the system to the control system, where it will carry some studies related using those data and identify the state of our power system. So let's say if they are predicting that the system is in alert state, then they will calculate some corrective actions that need to be taken to move the system from alert state to a secure state. And these control actions that they have decided, they will again implement it using wide area control system. So basically, these are advanced monitoring and control systems used in the power grids to gather the real-time data from a wide geographical area. And the technologies that is being used here, that is firstly we have the facial measurement units, that is PMU, which will sense the data. Then this data will be communicated through the communication infrastructure, and this infrastructure communication the data will be communicated to the control system, where using some data using display, or you can say smart display system, we'll be having a better situational awareness of the current system. Then we'll analyze it, the system analyze and analyze what the state of the system and try to enhance it. So basically the key features and components of this wide area monitoring systems include, firstly, the facial measurement units, as I said, PMUs. So these are the starting point for the ones, that is, these are installed at the buses in the power system. Basically, these PMUs we have in transmission system at the buses, and slowly we are also moving to, you can say, distribution small scale PMUs. Those are distribution system PMUs, micro PMUs, and they have the same function. So these PMUs, they are located at some selected buses due to, we can say, their cost related parameters. So these PMUs, they will sense, they can sense the quantities such as voltage, phasors, current phasors, if sometimes harmonics also, then frequency. So these all parameters they are able to calculate or sense, and then they will communicate it using the communication infrastructure, as we had studied in the week 3, as we had studied in the week 3, that is, as we had studied in week 3 through wireless or wired communication system. And when this data is available at the control system, we'll be having data integration and analysis of the data that is being available by the PMUs. And when we have the result of this data through the visualization tools available there, then we will be having awareness of the current system situation. And by the knowledge of the current system situations, we can take control actions to enhance our stability. And this can be done through the wide area control. So the applications for this WAM system include: firstly, we can detect the oscillations that are taking place in the system. Basically, we have different power oscillations or inter-area oscillations and other dynamic behaviors, and they will greatly impact the grid stability. And secondly, we can have post-event analysis. So let's say there was a fault in the system or some disturbances in the system. So these data we have recorded with us, and after the event has taken place, we can analyze this data to understand what actually led to the event, the so that in the future we may avoid this kind of situations. Then the next thing that we can do with the data is grid planning. So as we have been made available to a large number of data, load data, generated data, power flows. So using this data, we can uh, do the grid planning so that we may estimate the forecast, the load that is to grow in the years. So to meet that amount of load, we may have to set up generating power stations or transmission plants, and so these data will help us to do that. So we can say it is a key component that will help in modernizing our power grids to make it more smart, more resilient, and more with enhanced reliability and stability. So these monitoring systems, they help the grid operators, they help the engineers, and are also helping the researchers to understand the dynamic behavior of the power systems. And basically, they offer the real-time insight into the power grid stability and help to prevent disruptions. So the wide area monitoring system, we can say it contributes to the overall overall reliability and efficiency of the electrical networks. So the main four goals that were discussed in the week are real-time monitoring, post-disturbance analysis, adaptive protection, and power system restoration. So for real-time monitoring, we have when the PMUs will give the data of the voltage and current. So from this data, we can derive the power flows of the system. We can derive the transient, we can say voltage angle, that is dynamic angle of the system. And this real-time monitoring will help us to operate the grid in a better way in the real-time scenarios. Then secondly, post-disturbance analysis. Basically, we have a recorder systems, digital fault recorders. So they will record each and every event that is taking place in the system, and they are usually having high sampling rates. So we'll have huge data with us. And similarly, we can carry out the studies to understand why a event has taken place, so that we may avoid it into the future. Then adaptive protection. Obviously, in the if we have the data of the near real-time system, so we can take better control actions to avoid those situations. Hence, we have adaptive protection. Then lastly, power system restoration. Let's say even if after taking the adequate steps, just sorry, even if after taking the adequate steps, still some blackout or brownout has taken place in the system, then we need to restore it. And this restoration can be done effectively if we have the data at the real time available with us. So they will have the knowledge of the whole system during the restoration phases. So basically, we know there are two types of power system disturbances. One is blackout, and second one is brownout. So can you tell me what is the difference between these two scenarios, blackout and brownout? Both of them are disturbances to the power system. Both of them cause some unwanted behaviors. Anyone, if also if you know about blackout or brownout. So blackout, I think most of you must be knowing. It is when we have complete disruption of power. When there is no power, we can say the grid is not synchronized. The grid is totally off. So under that situation, we can say a complete blackout has took place, which was the scenario in the 2012 July, that is 30th July. And brownout is not the complete disruption of power. During brownout, what happens is we have the power supply, but it will be uh, reduced, or we can say partial power supply will be there. So basically, we may have faced a scenario where during the evening time the light gets dim, and so the basically what happens in the evening, then we have high amount of loads in the system. So what happens is amount of loads in the system. So what happens is we have high load. So to meet that amount of load, what your state utilities will do, it will lower the supply to your houses, which will lead to dimming of your lights. So this phenomenon is known as brownout. Basically, blackout is complete disruption of power, but brownout there will be uh, power supply. There will be not complete disruption of power, but the power supply will be lowered, and that will basically affect the voltage.
Ma'am, this brownout is automatically happening, or utilities are doing that?
Utilities are doing that knowingly, sometimes for their betterment.
I think why they are doing, because if you have to save your appliances, you will switch off, and
Yeah,
then automatically the load will be reduced. That is the intention.
that is we can say from the customer side. But what will happen even if let's say your 230-volt is what you should
Ma'am,
get.
your voice is breaking.
Oh, sorry. Is it audible now? Hello? Am I audible now? Shri.
Yes, madam, it is clear.
Okay. Okay, then we will. So even if the voltage reduces to 220, still the appliances will work. So that energy that the utilities will save in your house, maybe it will provide to some other. So both ways it will work. Basically, okay, I think. Then I think we discussed the components of these ones. Firstly, we started with this PMU who will sense the data or collect the data and give it to the phasor data constructor, that is PDC. So the PDC will then do the bad data detection, or it will timestamp these data using the signal from the GPS, and then it will send this data through a communication channel to the control center, sorry. And at the control center, the data will be analyzed and studies will be carried out, and the result they will be displayed on the big screens through the visualization tools. And when some they can give green if the system is in secure state, orange if it is in alert state, and red if you can say it is already in emergency state. So through these visualization tools, then we can say the control operators they are aware of the system in real time, and then they can carry out the necessary actions for the to protect the system, to increase the stability of the system according to the need. So we'll discuss in detail actually what is this wide area situational awareness. So firstly, the function that is being carried out here is data integration. Basically, when you have huge amount of data from various numerous number of sensors, from your meters, from the SCADA system, from the PMUs, so to manage this amount of data, it will organize this data, it will aggregate, it will remove some unwanted data, and it will then timestamp this data and send it to the control system, control centers. So last then it will also help in the real-time visualizations. So there will be big screens in the control centers. So from where you can have dynamic visualization of the current state of the power system. So let's say you have some important lines. So those power flows and those voltages, they will be always being monitored in the control center through the interactive dashboards, through graphs, through plots to help the system operator to understand the issues that may happen. There may be all they can also using the data of the current state, they can do some corrective analysis. Let's say at time t equal to t, you know the value of voltages, value of generation demands and everything. So you may carry some prediction that at t equal to t plus 1, maybe the system can go to alert state, maybe some unwanted actions will lead to the system moving towards alert state. So to avoid that in t plus 1, the system operator will give some control actions at t equal to t to avoid the future we can say disruptions to the system. Then obviously the third point is geographic information systems. So what will happen is uh, since these data are being collected over a wide area from different geographical locations, so this is operators can visualize like this data, this value of voltage or this value of power flow is coming from which physically location from the map. Then we have data analytics and algorithms. So basically, these algorithms will, as I said, they will identify the patterns and the trends, and they will do the predictive analysis that what will happen to the system at t plus 1 at the future based on the data that it is having right now. Then fifth one is event detection and alerting. So basically, what will happen? Uh, the system, the wide area monitoring system, it can detect the abnormal conditions. Let's say if voltage is going beyond the limit, if there is some, we can say, sudden disconnection of loads. So these disturbances, the system can, wide area monitoring system, it can automatically detect, and this will pop up as we can see a lot of notifications at the control system operators. So they'll get a pop-up notification that these disturbances are going at this particular place, so that the system operator can now calculate what corrective actions it has to take. Then moving on, we have grid stability assessment. So obviously this is also same. We'll analyze the data from the PMU and we'll access the different parameters of grid stability. Then decision support. Obviously, if you have this, like I can say, the operators have wider knowledge of the system, they can take better decisions for the system. Then historical data storage and analysis. Basically, you can store the data for post-event analysis, or if some regulatory policies that need to be enforced, or we can for generation expansion planning, for load forecasting or demand forecasting, for transmission expansion planning. So for all these studies, we need data, and this can be collected here. Ninth point, we have integration with control system. So basically, when you have, yeah, if you want to take some control actions, that you have to do through the with the help of control systems. And lastly, due to this data attacks that is currently in the trend now, so cyber, we have to protect our system, this wide area monitoring system, from cyber attacks also.
Excuse me, madam.
Yes,
Uh, can you explain what will be the role of data analytics, madam? Like, who will be taking of that care of that rolling in data analytics?
data analytics and algorithms, right? So basically, you get the data at the control system. Okay. Then they have processes like predefined codes and algorithms. So they'll feed in that data to
Like,
the
like who will be performing this task, madam? Like,
yeah
related to electrical person is going to do that, or any
no
other persons will
electrical
be?
only like in the RLDC centers, the NLDC center. These are the control centers for India, we can say. So these are responsible, like if an action is needed in northern region, so the RLDC of the north region, it will get some alert, let's say on its screen, that some line is getting overloaded. So they will then feed this overload situation to the already they have some codes with them. They'll run that code, and let's say they'll get the control action that to reduce this congestion in the city, maybe some generation has to be reduced, and that action then they'll obviously carry forward. Or if that line or that is let's say some important line that is under the jurisdiction of the NLDC or for the, or you can say it is for
Excuse
a
me,
interstate. Yeah.
your voice, your voice somewhat disturbance if it is happening.
Okay.
Not clear somewhat.
Okay, I'll tell again. So, if the alert is for the regional equipments, let's say some within the state only, some disturbance has taken place, then obviously the actions will be taken. These data analytics they will be carried out by the SLDCs. But let's say if the disturbances is for some line that is connecting the interstates or inter regions, then this will come under the jurisdiction of the NLDC at the central level. So similarly, so is it clear what I said?
Yes, yes, okay, man. Continue.
Okay, thank you. So voice is clear, I hope. I'll try to speak louder if it is just not clear. Then we'll basically study here the synchronized facial measurement system. So how PMU is detect basically PMU data we have.
Ma'am, again your voice is breaking.
Oh, is it for everyone? So voice is low or is it like some connectivity issue?
Like, you are
Your
sitting in
voice is low, ma'am.
you
It's
are sitting in
audible, but it is very low.
low, and you are sitting somewhere in closed area, so there are some resound like we are listening.
Okay, okay, okay. Okay, I'll speak loudly now. So now we'll discuss about synchronized facial measurement systems. So basically, how the PMU for the PMU will detect the datas that whole system will study now. So basically, this is a monitoring technology in power systems that will be used to capture and analyze the phasors in the system, the phasor of the voltage, the phasor of the current located across the grid.
Oh, 1 second, madam. You explained about they will be using some logarithms according to it. What kind of logarithms will be using there, madam, especially in data analytics?
Okay, algorithms like let's say for power flow, then you have to do you must be aware of optimal power flow or
Yes, madam. Oh,
so what is happening optimal power flow, there is load flow also. These PMUs they don't give the voltage and angle at each buses, like they'll give you at some location, at some selected location. So using this measurements or using this data, then we have to carry out state estimation. That is one of the studies they will do. So the state estimation study will then give the voltage magnitude and angle at each and every bus of the system. So firstly, then we got the voltage, magnitude and angle. So from these phasors, then again we can because everything is related to V and I. After getting V and I,
Madam, excuse me. Can you take any word, a blank word, and can you explain how the flow it will be then?
okay. So basically, from this, you can say PMU, you got the V delta current also. And let's say it's like 5 at some buses. Some selected buses where these devices are located or they have been installed. Okay. So using this, we have the study that is in power system is state estimation. So using this real-time data, using the we'll carry out the state estimation to get the value of voltage, angle, and data at all buses in the power system. Okay, so let's say uh, you have a system like this where you had PMUs at these locations only. So you got the voltage, magnitude, and angle at only these two buses. So using state estimation, you got the voltage, magnitude, and angle at each and every bus. Okay, everywhere. Now,
Okay, ma'am.
if this is known, to calculate the power flowing to the line, we can utilize these values, right? You have the formula for P, right? Pij
Mm-hmm.
equal to Vi minus Vj upon delta Ij. Like this is the for transmission system. You can have detailed analysis also. So from this, because once we know V and I, we can calculate V power flowing, Pij, Qij, then you have Q generated also that information obviously system operator is having. Q load also if there is some changes that will also so you can calculate the Q injected also. Q injected and P injected, that is Q generated minus Q demand. Basically let's say I calculated this P and I found out that this line is overloaded. So then I will forward it to the we have our algorithm called security constraint optimal power flow, and it will give me the corrective actions so that we can relieve the congestion of the line. So basically these kind of studies will be taken. Or let's say you had a huge load here, P load, and it became zero. So under this case, what rescheduling you have to do, right? Reschedule the generator, and so for that you can do economic dispatch or optimal power flow. So I hope this is clear. So these are kind of the studies that you can do utilizing the data that is being made available by the PMS.
Okay, okay, madam. Thanks. One more question, madam. See,
Yeah.
suppose assume that we are in smart grid.
Mm-hmm.
Assume that we are implemented the smart grid all over the India. So even though if renewable integration, if it is there also in 2050, we
Mm-hmm.
will be almost depending upon the fossil fuels. Somewhat we
Depending.
might be depend.
Okay.
Huh. So in that case, with this data, I'm going to save the fossil fuel consumption. Like, see, suppose if solar integration, solar generation, it is there.
Mm-hmm.
Uh, 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 sup- mm, with, with this data, we may be saving any consumption of the fossil fuels.
Consumption of means I am not basically you're saying the data that is being stored, whether we are calculating the amount of fossil fuel that is like, let's say we need 100 megawatt of power for our system. So this data that how much power is coming from fossil fuel, how much from solar, how much from wind. This breakup you are saying.
Mm-hmm. Like that.
So this is already being stored. No, you can see in the Ministry of Power UK if you go to the site. So you will have like total energy mix of the India today, or some they'll be having a pie chart type of thing where they will tell the percentage of power that is we are getting from fossil fuel, from wind, hydro, solar. So these are data we are doing it from now only. You go to Ministry of Power and there will be
Yes,
three.
yes, madam. Suppose if assume that my generator is generating 100 megawatt of power.
Uh,
So in daytime, I required only 50 megawatt of power.
mhm.
So in that, I am going to put the same amount of coal in that to generate 100 megawatt
So
or 50
that
megawatt.
so basically that is not that will not happen in real time. So you have to tell the thermal power plants day ahead. No, you cannot say at the next time block at within 15 minutes I need 50 megawatt of power. So these dispatches carried out in the previous day as we had told you, because we have the historical data even for renewables also we're predicting some amount of data. No, that it is not like we are 100% uncertain. There is a band, let's say 10% we are having uncertainty, that we may estimate that we may have solar of 2 megawatt. So this 2 megawatt it may change to let's say 1 megawatt or something like that. So utilizing this uh, you can say forecast of the load of these renewables, then we'll carry out the dispatch for the whole system for the coal power plants. And this we can say timetable or schedule for the whole power system will be carried out 24
Uh,
hours before.
Madam, can I explain, madam?
Yeah, sure, sir.
The point is all the coal-based power plants, they only feed the base load, okay, and base load is always constant. If you see in any load curve, base load is always constant, and these coal plants, okay, they always operate on the rated power. They cannot reduce power. So that is why whenever there is peak demand, we have to either switch on the additional captive plants which are not in use, or we have to increase our hydral generation. That is how that peak load is scattered. Similarly, nuclear power plants, they always, okay, run in the base load only. They are also not reducing their power. So basically, though we have to classify power plants with the peak load power plants or base load power plants. Normally, small hydro plants or the hydro plants, they take care about the peak load, and coal and nuclear power plants, they take care about the base load. Sorry.
Yes, and
Even in that situation, we may go for pumped hydro storage systems also. Whenever there is a only base load power plants, base load, we may switch over into pumped hydro storage systems. So that will be re-energized. Whenever if we get high peak loads with the help of pumped hydro storage, we will again generate the electricity and we may utilize it.
Yes,
so
that is you are calling about the pump hydro storage, na? That is there.
Yeah, yeah, yes, sir. Yes, sir.
So basically, we have like flexible generations, and some generation like coal power plants conventional. They involve some startup costs, shutdown costs. So those all will be considered in the economic dispatch. This hydros and hydropower plants or they pumped hydro storage as server telling, they involve no cost. Even if they can be ramped at high level, they can be switched off. But the coal power plants, they will come with a cost. So in order to reduce this cost, this will be taken care in the optimization problem and will not change the schedules of this, as they said, fixed generators, so as to avoid the extra cost incurment. Okay.
Okay, well, thank you.
Uh, I think we were with this synchronized facial measurement systems. So obviously there we are having PMUs there installed at some buses who are like measuring the instantaneous values of voltage and current. Then they are having some. Uh, yes, someone wants to speak. Mr. Elango sir, do you want to speak? Mr. MK Elango sir, you have raised your hand.
No, ma'am. No.
Okay, okay. So, and then we have PDCs, patient data constructor concentrators, and then synchronization. Obviously, we talked it in the previous week and this week also, that we are having a common global positioning clock which acts as a reference for all the PMUs in the system, and accordingly we are timestamping the data from the PMUs. And then obviously we need communication infrastructure for all. So this is how the communication between a PMU and PDC is taking place. Basically, the PDC will first ask like the data that you'll give in what format or what frame, and the PMU will consider this request and send the format of the data that it is going to send. Then PDC again will acknowledge that okay, this is acceptable to me, and then the data that will flow to the PDC, and when required, obviously the PDC will send the stop data command to the PMUs. Then this wide area monitoring system applications we have over generation, transmission, and distribution. So for the generators, we have to monitor the angle of the generators, for the transient angle stability and the operating status, whether they are operating at full capacity, half, or they are shut down, for how long they have been shut down. These all data is available here. Then for transmission, we can use this data to carry out, as I said, state estimation to calculate the voltage, magnitude, and angle at each and every bar. Basically, the states at each and every bus of the power system. Then also we can, if we have the data for generation, P generation and P load, we can also carry out load flow. That will also again compute voltage, magnitude, and angle. Then we have optimal power flow. Basically, optimal power flow. Before that, let's discuss what is economic dispatch. In economic dispatch, what we are trying to do is minimize the generation cost of the generators to meet some amount of load. Okay, so that is economic dispatch. So economic dispatch, we are not considering the line limits of the transmission lines. So if along with economic dispatch we consider the line limits, we'll get optimal power flow. Obviously we can do load forecasting also using the data we have. Similarly, in the distribution side, we'll be having substation automation, feeder automation, and lastly consumer side automation. For substation automation, as we know, we can have reconfiguration, we can have service restoration, we can have voltage controls, we can have voltage control, we can have automatic reclosure of feeders or reconfiguration, as I said. So again, sorry, the reconfiguration will come under feeder automation. So automate the feeders, switching of the feeders, feeder voltage controls, and obviously the active and reactive power control to maintain the voltage, angle, and magnitude. And lastly, for the consumer side, we discussed this in previous week for advanced metering infrastructure and automatic meter reading. So this data resources that we have, were divided into two parts: operational data and non-operational data. So the data that is coming from SCADA and PMUs, those stream of data are the operational data, and the non-operational data includes the data that we're getting from the digital fault recorders, digital protective relay, and the circuit breaker monitoring. So basically, these are sequence of events that are going in the power system. These are at lower sampling rates, these are at higher sampling rates. So basically, digital fault recorder, it will record the events that is taking place in the power system for post disturbance event analysis. Protective relay, it will sense the voltage and current, it will compare it to something, and if it is above or below some threshold, it will give the signal to the circuit breaker to operate. And the circuit breaker, it can operate, we can say, manually, or nowadays this is also being automated. Then you have also seen this block diagram in the week lectures. So basically, for this PMU, we have 4 satellites on 6 orbits. So they are inclined with 60-degree angle with each other, and with the equator of the Earth, they are inclined at a rough angle of 55 degrees. And each satellite is covering 42% of the globe, and they are at a height of this 10,898 miles. So basically, this is the block diagram how the PMU will get that get the data and communicate it finally through the modem sequencing. So the two important components that you can see here are this anti-aliasing filters and phase lock oscillator. Because previously, this of
Ma'am, what do you mean by madam?
this modems.
Yeah, ma'am.
Basically, these will finally, when we get the data here, it will transmit the data. These are part of communication system. This will transmit the data to the control centers. Previously, when we did not have this Wi-Fi, if you remember, for this BSNL also, we used to install these modems in our houses back in 2010, 2012, those eras. Okay,
Okay.
okay, thank you. Then, so we'll discuss what is this basically anti-aliasing filters. So you must have studied that the sampling frequency. Obviously, we need higher frequency to get better data. But if this is greater than some threshold, that is 2 times the magnitude, the fundamental, then the signal, the higher frequency signals, they will start to appear in your waveforms and they will distort the waveforms. So for that, we'll be having anti-aliasing filters. So basically, when the high frequency components, they'll start to appear when the sampling frequency exceeds the Nyquist frequency, and they'll start to appear as lower frequency components in the sampling data. Is my screen visible? Hello, is my screen visible or it went off? I think.
No, ma'am, screen is not visible.
Okay, just a second. I think we'll reshare. Okay, I think this is fine now.
Now it's visible, ma'am.
Thank you, sir. So this is the primary, we can say, function of anti-aliasing filters, to remove this unwanted high frequency components. Then we had phase lock oscillator. Basically, it is for the time synchronization process. It will receive the signal from the GPS and it will, you can say, log this in the PMUs so that we can have time stampings. These I think we know. The PMUs, what they can measure. They can measure the positive sequence voltage in current phases, and they can sometimes measure the frequency and rate of change of frequency, and also it may be customized to measure harmonics and
Madam, if there is transients in power system,
true.
so then the transients have more frequency than the normal one, say 50 hertz.
Okay.
So at that time, PMU will automatically cater for the higher frequency rate. That is what is anti-aliasing.
No, no, this is for the frequency of the data that it is getting. What we are talking about is oscillations, no? So this will get at the control center. But PMU's first, this anti-aliasing filter, it will happen at the PMU station. But these oscillations that you'll get is at the control system, control center level, no?
Some of the transients are very small. So how that sampling of that particular small period is taken? That is my question. It may,
Voltage.
it may happen that during that microsecond, the transient is very peak and it may not be recorded by PMU because sampling rate is, say, suppose 50 hertz is there, you are taking sampling as 100 hertz because of the double of the 50 hertz what we use.
Mm-hmm. Okay, rightly pointed out. Actually, I don't have the answer right now. If someone else has the answer, maybe I can look up and answer you for the next week. Also, if someone else has the answer to this, they can answer now.
First question is understood or not?
Yes, I got your question, sir.
Okay.
Okay. Then basically, this phaser, because after sampling, we know if we have a sinusoidal signal here, so this magnitude, the circle represents the magnitude here. Basically, we can say these arrows or these vectors, those represent this length will represent the magnitude, and its inclination will represent the phasors. Basically, this is a anti-clockwise rotating phasor of magnitude, we can say, or length bn, peak value of this signal, and angle is at the position here, you can say. So how this PMU is calculating the phasor using the samples, that is done with the help of, sorry, discrete Fourier transform. So these formulas I think you have seen in the lecture. So basically, after getting this sample Vn, n is the time instant of the sample, we multiply it with the Fourier coefficient. Basically, this is complex, cos times this angle plus j times this angle. So this is basically what you get here. N is the total number of samples. So utilizing this DFT, we get the real and imaginary part of this phasor, and basically the magnitude will be square root of V real square plus V imaginary square, and the angle will be minus tan inverse of V imaginary upon V real. So basically, let's take an example. Let's say you have a, after sampling, you get this data at certain time steps. You can say at instant 0.1, the magnitude was this, or sorry, the sample that you got is this, and similarly proceeding to the time. So from this data, can we say what is the sampling frequency? Let's say this is for a 50 hertz signal. If this is a 50 hertz signal. So can we calculate the sampling frequency? So can we see that we get some repetitive data, see 41.47, some increase, then in the negative side, and again here we are getting this data equal to
It is 400 hertz.
400 Hz. Okay, can we have one answer? I think we got 400 Hz. Someone else? Anyone else? Basically, this data at t equal to 0.12 is same as t equal to 0.1. So we can say from t equal to 0.1 to t equal to 0.1175, we are completing one cycle. Is that okay? Okay. So we'll count how many samples we got then in one cycle. So if we count here, starting from 1, 2, 3, 4, so we got 8 samples. 8 samples in one cycle, right? So now can someone tell me if we have 8 samples? So basically this number of samples, this will be equal to the sampling frequency divided by a fundamental frequency. So from here you can get then sampling frequency as 8 into 50, that is 400. So this is right. So I have to this, it is clear. So basically one cycle is from T, we are having 8 samples. So using these samples we'll calculate the phasor for this waveform. So let's say here we took the sample from, let's say this time step 0.1025 to 0.12, because again for at t equal to 0.1025 we had 101.01. It is again repeating here. So that means our cycle is from this to this. So we'll take it to the next window. So from this data we have entered this value of voltage samples that we had. Then this n is the sample number. So we take this from n equal to, if we take from n equal to 0, so here we'll end at n equal to 7, because we had 8 samples, right, and we started from 0. So if we substitute 0 here, so cos of 0 will get 1 and sine of 0 will get 0, and then we'll multiply this with the voltage sample that we had, this cos component and this sine component, to basically get the value of these. And from here, then here we'll put n equal to 1. So if we put n equal to 1, we get 2 pi by into 1 upon 8, basically pi by 4 or 45 degrees. So sine and cos will both be equal up to 1 upon root 2. And similarly, we fill this data for by varying n from 0 to 7, and we get the value of cos and sine as these, and then we multiply the voltage sample at each time step. the corresponding value of cos or sine, and we'll get these values. Then we'll sum up here to get the variable and PMRF. So we got basically these part, and then we have to multiply this by this factor to get the variable and PMRF. So basically we can say from this data, if I consider this as 9, I will take this as my outer window, let's say, and this as my inner window. Means from here we rejected one data sample for this and added a sample here. So basically from 0.1 to here 0.11575, and then this second window. So how these phasors will vary, if you see here, basically they'll have the same magnitude. But can we tell why we are getting this phase difference between these two consecutive samples or phasors? Sorry, between these consecutive phasors.
Madam, repeat the question. Question I not
Uh,
understand.
this for window 1, we got this value of phasor, magnitude and angle. For window 2, we got this value of magnitude and angle. So you can see their magnitudes are same, but they are having some phasor difference. So why this phasor difference we are getting? Like
Ma'am,
if you compute it,
this is a polar plot of rectangular plot. So that phasor is moving, na ma'am. It is
but this they are differing by 45 degrees. So why? My question is why this they are differing by 45 degrees, not by let's say 50 or 60 degrees. Can anyone have a guess here?
Whether it is inductive load, according to the load also it will be.
Oh, that's true. I'm not saying that this is minus. Obviously, this is inductive, so we got minus maybe. But why these phasors are separated by angle of 45 degree, not by some other angle? Why not by 50 degrees? Why not by 60 degrees? They are having a relation. So basically, if you remember, we had 8 samples in a cycle, right? 8 sample for one cycle. So we can say 8 sample for 360 degrees, right? So for one sample, it will be 360 by 8. So if you divide 360 by 8, you'll get 45 degrees. So due to this, each phasor that will get by here, they will be having same magnitude but they will differ by an angle of 45 degrees. Basically, they are rotating in anti-clockwise. So likewise, you will get here. So if you guess here at this position, it will be again 77.45, and its angle will be this minus 22.75 plus 45. So I'll get 22.25. It is coming positive. We can see here, obviously, if you consider this as 0, so this wise you will get plus 22.5. So I hope this is clear now.
Ma'am, in DFT, always we have to take 8 samples a
No,
cycle.
no, it is this. For example, we had considered the sampling frequency as 400 hertz.
Okay.
Depending upon, like, in real, actually you'll be having higher resolution data. For this example, we are taking here 8 samples. So depending upon the sample rate, this phasor angle will also vary. Okay, so this was the conventional DFT. Then we'll see some variants of it. First is this recursive DFT. So what we are doing here is, if you see, for this outer V1 window and V2 window, they are having same sample of data from here to here. The only difference is window 1 is having this one additional for first window, and second window is having this data point. Rest all data points are same. So this relation, if we utilize, and you may have also seen in the lectures, so we can derive that directly. We can compute this V2 phasor using the information of V1 phasor and the relation. So basically V8 is, this is V8, this was V0. So as we this shifted from this window, so we discarded the old measurement, and we added the new measurement. So this V2 phasor can be calculated using the relation here. So by doing this, we can say the computational burden will be reduced, because we are not again redoing the DFT for whole 8 data points once again. We are just discarding the older data and adding the new data that we are having here. And using the knowledge of the previous instant phasor, we are computing phasor for the next. Another variant that we have is half cycle DFT. So basically, if you see here, these are positive, and again these parts are repeating in the negative part. So similarly, if we see, this is, we can say, up to first half cycle, and similarly for the next window, if we move for the next half cycle, you can get this relation. So this half cycle DFT, again it will be computationally fast because you are using less number of data points here. Similarly, it is computed here, we can see, but here n is from 0 to 3. Basically, you have 4 samples now, not 8. So this is for n equal to 0, n equal to 1, n equal to 2, and n equal to 3. So similarly, we can compute, and using this, you will again get the same value of the phasor as you get for a full cycle DFT. So the next technique that we studied in the lecture for this week was least square error phasor estimation. So basically, when we are having some measurements, how we can compute these phasors. So here at, let's say, time samples, time instance t1 to t2 to tn, we are having some measurements m1, m2, mn. Then we'll estimate, these are estimated values, and we'll compute the error that we're getting from the measured values, right? And we will try to minimize this error. So our objective is to minimize E. So what we do here basically is minimize E transpose E. But why we are doing this instead of just minimizing the error? Can anyone take a guess here?
What is the question, ma'am? Please repeat the question.
Why, like our aim is to minimize this error, no? So why not just minimize this error E, and why we are going for minimizing the squared error E transpose E?
Because, because we are taking a distance from each measurement, and we are that linear regression is doing. So we are calculating distance between the
Hmm.
regression and the deviation from that what is the hypothetical line what we want to plot.
Hmm. So what is why not just take E? Why to take the squared error?
No, ma'am, because it is a distance, no? So that is why we have to square it. It may be positive or negative. Deviation may be positive or negative. So that is why we have to take square error.
Yeah. So basically, this deviation, as I said, it may be positive or negative. So if you just minimize this, then at some point, if the deviation is, let's say, negative, so what will happen is you will be then minimizing the positive error, you will be minimizing negative, which will implies that you are maximizing the error, which is not our objective. So hence, we are this. Okay. So hence, what we are doing is minimizing the squared error, and these are all matrix form. So for matrix square, we can represent as just,
Screen is not visible, ma'am.
yeah, yeah. I'm just resharing one second. I think it's visible now, right?
Yes, madam,
Yeah,
visible.
ma'am, it's
Okay,
visible.
okay. Sorry for the disruption actually. So what I was saying is we are minimizing the squared error, so that we'll always minimize this error and not at any case maximize it. And these are in matrices. So for the matrix, we can represent it as E transpose times E. And when, and this, if you minimize it, then you'll get, basically if you take the, to minimize it, what we have to do, we have to differentiate this, let's say objective J with respect to X, and compute it to 0, and the second, so this necessary and sufficient condition as we say it. So if we take the second differential, and if it's minimum, so obviously this has to be greater than 0, or for matrix we say that it will be a semi-definite positive matrix. Then we can say that the solution that we got is for minimum. So basically if you do this, what you get is here this one, and this whole matrix is called the pseudo inverse of A, this computation that you are doing here. And this matrix, then again, if you multiply by the measurements that you already have, you will get the estimated phasor of the voltage or current or the sample that you are taking. And last in the last lecture, I think what you studied was some relay characteristics, that is relay reliability, dependability, and security. So these were the relations that was there. For reliability, it is number of trips divided upon desired trips plus number of incorrect trips. For dependability, we can say it is correct trips upon desired trips, and for security, it is correct trips upon number of trips. So we'll move to the Q&A. So the first question is the sample rate.
Option D, ma'am.
Okay, we got one D. Anyone else? If you are
D, ma'am.
if you're comfortable, you can type in the chat box also. If you are unable to unmute. Okay, I got two Ds. Okay. Anyone else? Okay. We got another D.
Ma'am, the same questions was there in the last, what you say, session. So can you change the questions, different question sets?
Last session in the sense, my last session was last.
No, no,
Oh,
no. Prior to your
4
session.
to 6, ma'am.
So
okay.
same. So can I request you to change the question, change the questions?
Basically, we do not coordinate among themselves. So this is intended that uh, maybe we can say we run three sessions in during the week, so that
Session is okay, but my request is for at least questions we shall discuss. What is it differently?
I think
Sir,
you can.
this question only same. Remaining questions may not be same, sir.
This is I am talking about 5 sessions. Okay, you can see the same questions is repeating in all the sessions. So this is my suggestions to you. You can take the point and you can at least change the question sets. That is my request to you.
I'll take this and coordinate with my other TAs from the other sessions, and then we'll. For this session, it will not be possible because I have already seen this one.
No, ma'am. Now you can. Okay, we'll revise. No, not an issue.
Okay, okay. Then from next week, I'll coordinate with my other fellow TAs and we'll discuss upon this issue. But what may happen is basically some may not, or it was the case that all those who were present in the meeting were also present in the previous session.
Majority, ma'am. We are the repeaters.
Okay, or not repeaters, we can say the regulars, sincere maybe. Okay, okay, I'll discuss it. Okay.
Even, ma'am, if someone wants to see the recorded session
Uh,
again, that same question will not what you say should be discussed. That is my request to you.
recorded session, recording will be
After,
this.
like all the 3 sessions which is conducted, na
Ha ha
you it is all recorded in that, and that is link is there.
ha
So
ha.
if you see the all the questions are more or less same.
Okay, okay, I'll take this forward. Okay, so first question, this was the correct answer basically. Digital fault recorder.
And any reason, ma'am? Any reason why it is from 64 to 356?
So digital fault recorder, it is high sampling rate. So no, we cannot like enforce that why at this rate. You can say the range must be at the higher side, but why this? This is basically you can say informative or data type. Okay. Then the next thing we had was
In the instruments, can we have a different settings also, like we operator can set, or it is all from 64 to 256?
see
So
op
can I set it up at 100 samples per cycle? That is my question.
see operator may not be always the owner of this instrument, right? So this the rate at which it will say, let's say it is at some substation, and it will send to the control center. So maybe if the control center request for some higher rate, that is possible or not, that also again I am not sure of. So that is the thing. So basically this must be the standards that they are following.
So why my question is because if from HMI what we have studied,
Hmm.
so if some DFR is set up at 100 samples, some DFR is set up at 200 samples, okay, because that is also in the range. So
So
then there is so mismatch will happen, and then the purpose of what you say combined data transfer will not happen. That is my question.
combined data transfer, I couldn't get your word.
Since all the DFR they give to that PDU,
Huh.
na,
Hmm.
PD, data
PDC.
consent, PDC. So then, if the sampling is mismatched between someone is sending more, someone is sending less, so then there may be problem. That is my practical aspect. What I am asking.
Sir, that's why we are following some standardization, sir, for each and every categories while designing, monitoring, everything we have certain standards like IEEE and IEC.
Standards will only give the range, na, say suppose 64 to 356. But now my question is two DFR. One is at set up at 100 samples, another is set up at 200 samples. Now that once they are transmitting the data to concentrator, so that data rate will be the mismatch will be there. Na? That is my practical ask question. What I want to say.
If according to my understanding as of now, I can say, if you remember, we had two types of data, right? Operational and non-operational. So these are for recording of events. These data we are not like utilizing this for further studies. Like if in the case of PMUs or SCADA, what we are doing is we are utilizing this for other, like for we can say sequence of data studies. But this circuit breaker relay and fault recorder, they are recording some sessions, or we can say they are recording the data for some post disturbance analysis. So let's say some contingency has taken place, some line has tripped. So one digital fault recorder, it has recorded 10 samples of voltages. One recorder has recorded 100 samples. But this is recording is with us when the contingency has happened. So using this data, then we are not going to like monitor or give some control actions. This is for post disturbance analysis, right? So this may not affect the studies. Basically, they are reporters. So some reporter is giving some subset of the event, other is giving, let's say, more a more greater overview of the system. So combined we can then have a greater knowledge of what happened during that event.
Okay, madam.
Okay. Then the next, similarly, the circuit breaker monitor data is also, what is the data format, not formed, basically.
It's D, ma'am. D.
Comtrade.
D, ma'am.
Okay, so okay, this was Comtrade format, and I think in the slides, in the lecture sessions, it was in detail. Uh, Then we had the next question. Which of the following phasor estimation techniques can filter exponential DC components?
Least square estimation technique, ma'am.
We got one week there.
All the questions are repeated, ma'am.
Ma'am,
Okay,
Yeah, ma'am.
madam,
Same questions will be there.
ma'am, how it is B square? Can anyone explain?
okay. Um, Again, if I had one example, then I could go through it. Basically, this sample, let's say, if you had some fundamental plus, let's say, then we had some, this will again be different. Let's say this was fundamental. This is third harmonics, cos of 3 omega t plus phi 3 and plus, let's say I had some this DC component, right? So from here I need basically for phasor, basically I need both real and imaginary, sorry, x3, x4, and here it will have one component. So then we are trying to we are trying to find five unknowns, that is x, and then we'll be having some samples, right, and measurements, or we can say. So these measurements, they need to be even five. Let's say we have some 10. So again, using these measurements and calculating this pseudo inverse that we had seen in the earlier slide. So if you then again pre-multiply this with the measurements, pseudo inverse time measurements, you will get x12, x5, and then you can utilize that to calculate its magnitude as x1 square plus x2 square, and similarly for here, and this will be directly the magnitude will give you x5. So here, and if you want, maybe the data that I had given you did not have this right here, right? Maybe you can take one more type of data where there is some decaying DC component or DC component in the signal, and try to compute the DFT, and then you'll find out that it will not be able to reflect. Okay, this is, I think, again factual.
This is also a repeated question, ma'am.
How this I get for this session, obviously all this will be repeated. From next
Madam,
session we'll
The answer is 42%, ma'am.
if we see, ideally speaking, three satellite will cover and the entire globe. So though we have 24 satellite, which is practical one, but if you
Mhm.
see theoretically,
Right.
three satellite will cover the entire globe. So one satellite will not cover more than 33, 33%. So how this 42 is coming once we are having 42, sorry, 24 satellite? That is my question.
So what we had is
If you
20.
if you if you see Earth as a center and then you put the three satellite in 120-degree, they will
Hmm.
cover entire Earth. So, but now we are using what you say. So one satellite will cover 60%. Six, sorry, six, 180 degree. 180 degree. So 180 degree, 360, 120 degrees. So suppose one at least one satellite will cover 120 degrees. Sorry, 120 degree.
Hmm.
So now we have 24 satellites. So how it is 42%?
No, what, as much as I remember the stats, let's go through this together. So we had 24 satellites in six orbits with four satellite in each orbit, right?
Yes. That is
And
why we have four satellite, one
huh,
to cover.
and each orbit they are inclined to each other with 60 degrees, right? So basically,
Basically, we have to divide 360 by 4. That is my answer.
no, 360 by I think 6. No, we have how many orbits? If I say how to swim. So if I represent the orbit by, let's say, straight lines, so let's say 1, 2, 3, 4, and there will be another two parts, right? Let's say. So likewise, and each orbit we are having 4 satellites. So if we divide 360 degree, according to my knowledge, then it should be that each orbit is covering 60 degrees.
60 degrees, yes.
And again, for each 60 degrees, we are having dedicated 4 satellites. But if we have a path here, and let's say I have 4 satellites, so this will be less than 60 degrees, that is understood. But why 42 and why not 22? That is a separate discussion, I think. So, and one more information what we had is from the plane, equator or equatorial plane, they are at 55 degrees, right? So I could come up to only this. Then maybe we can see like maybe some geography maybe here, that from one satellite here and they have the earth here, what the projection they may be having, that may be coming as 42 according to me, but I'm not sure of.
Okay, okay, ma'am. We will find
Okay.
out this.
Then next we had operational and non-operational data. So which of this is not non-operational data?
And it is all, ma'am.
All of the above.
Hmm. So these all of these
All of
are
the above, ma'am.
non-operational data.
Ma'am, this is also repeated.
I get you. Obviously, for this session, everything will be repeated. I cannot do right now change the question, but for next session onwards, we'll talk. Like I'll talk with other fellow teams and we'll try to take care of this. So, if a signal has fundamental frequency of 100 hertz and sampling frequency of this, then number of samples per cycle.
300, ma'am.
Is it 300 that you got? I have doubt here. Basically, what we had also seen during this session, that number of samples was
Ma'am,
sample.
number of samples means samples frequency by fundamental frequency. On
So if we do this, are we getting 300? Because here it is 4 zeros, 30,000. And with that, again, we are having kilohertz and fundamental is 100. So according to me, it should be 300 times 10 to the power 3. Or if anyone can tell if they are getting 300, if I am wrong, or they agree with my solution.
This multiply by 1000 is not a correct one. So 300 is the correct one answer.
Why will not multiply by 1000? Because this is the formula we got.
No, no. This in the if you see the
No, ma'am, that is in kilowatt.
in this question, ma'am, it is written a thousand. This thousand has no significance. So Fs by m is the correct answer.
Fs by m is correct answer, right? So what is Fs here?
Ma'am, that 1000 is available in the question itself, ma'am. Last part. After the dash
Ha
into
ha.
1000.
That I gave here, but that is what I was asking because previously what they gave was 300 only. So that what I found wrong. That's why I added it here. It was not available previously. Okay. Again, I think this is also same for you all, but still we'll go through this. So from here, basically we get the number of samples as
50.
50. And as we know, this 50 samples correspond to
360
360. So what is one sample?
is 7.2 degree, ma'am.
7.2. Okay, we had three.
Ma'am, how it becomes 7.2, ma'am? Can you
Yes, sir. Yes, sir.
explain?
Sure, sir. Sir, we got 50 samples per cycle, right? So one cycle, if we start from 0 to pi to 2 pi, so 50 samples, 2 pi. So one sample, how much angle? That also likewise we discussed here, right? While this one, that we had 8 samples. So if we calculate the phasor at for the each time instant, we'll get the same value of magnitude, but these will be separated by this angle 45 degree, and here also 45 degree we got by 8 samples for 360 degree. So one sample is covering 45 degrees, so each will be
Thanks, ma'am.
separated by 45. And similarly here, if we take here, so basically it will be 360 by 50. So it will be 7.2 degrees. Then we had the relay percentage of security,
C is the answer, ma'am.
correct trips by number of trips.
Option
See,
C.
ma'am.
Okay, these are repetitive, I understand. So the advantages are
All.
all.
Ma'am, we hope that similar type of question will come in final exam.
Final exam, they will be handled by different set of TAs, I think. So
Uh,
I can't
uh,
guarantee what will happen.
no, but pattern should be same what we are discussing here. Then only it will help us.
Actually, I don't have knowledge, so maybe it is how they get. Okay, this was again for zero crossing. So in the signal, the first zero crossing occurred at it's 0.01 second, and the ninth zero crossing occurred at 0.05 second. Then what will be the frequency of the signal? I think you had a formula for this. If someone can do.
200 is the answer, ma'am.
Okay, this is what is 1 minus 1 by 2. So here m is equal to 9. So what we get? 8 minus 1, 4 into 1 by, this is 0.04. So you will get here 100. The frequency of the signal is 100 hertz. Okay, so as I got, one suggestion is for different set of questions. Okay, okay. And anything else before we wrap up the session? Anywhere in So I think the content may be different, but the content also, matlab, overall, we may be discussing the same topic, but the way of presentation and the in-depth content, they may be different. But we are getting the same set of question answers for that Q&A session, right?
Yes, ma'am.
Okay. So for all, like, okay, for Tuesday batch also, then we'll get this. Yeah. Yes, someone wanted to speak. Okay. So these slides, again, if anyone wants to go through, so these are available in this Google Drive. So if you are aware of. And anything else?
Madam, can you give some reference who can give me practical how this auctioning of power can take place? 15 minutes of what we have discussed many times. And say, suppose if I want to buy a
Okay.
power for how I can go about that?
Okay. So is it what first question is you
Like
have
like
three.
like like we do trading in stock, na? Can we get power? Uh, if someone knows this practical aspect, and if you can give email, I can discuss separately, not in this class. But
Huh.
I need a person professional.
So
Uh,
see, professional. I also don't know anyone. What is available in the government websites, that only I can give you. So there are basically three exchanges for energy in India. So firstly, you have to decide that with which exchange platform you want to connect. After that, when you go through which exchange you have chosen, then each exchange will be having different set of, like, their, you can say, requirement or prerequisite. For person, I think if you visit the exchange site, then you may find a contact email there. But a physical person or some physical, like, specific people, I can't. But you may get there for the community.
I had mailed to IDX that whatever the web page they have given the mail,
Hmm.
but
You did not
they
get
said
any.
they
Okay.
said ki come by your state electricity authority. They said like that. Then what is the use of the IDX then?
So, did you, like, what is the amount of power that you want to trade basically? Is it in their bracket?
Yes, yes. So they in that IDX they said ki 100 kVA and above you can purchase.
Okay.
I said ki I will purchase 2000 kVA, not an issue.
Okay.
But how to go about this? So they said ki come via state. The mail come like that.
Oh, you mailed to which one of the exchanges? To IEX?
IDX,
IDX. Okay.
which is taking 90% of stock.
90%. Yeah, true, I get. So I don't know why they are refraining from that.
He must be
Maybe,
he must be thinking that some student is asking like that.
huh.
Some
So what may be that there may be some form available in their website, no? Like something, some documents you need to submit. So what about what if
that
you
is
apply?
the ma'am, that is the what you say contract. That is the
Uh-huh.
contract which we can do after that. But
No,
before
before
that,
that you'll get the license, no? For
no, no.
getting the license, I think you need to submit some documents, right?
For some license also some what you say knowledge is required, na? Like who will give that knowledge? That is my question.
For getting the license, like how to fill those, I think consultancy they are coming up, but they are like, Renew Power is there, Capgemini is there, but they can handle for not for individuals. It does not come up in India for individuals. So I don't know if they
No,
will.
I'm not talking about individual. I'm talking about my organization. Not directly want to get power for my organization.
Hmm. So which state actually you are residing now? This organization or where?
I'm at presently at Assam.
Assam. Okay. Uh, so I don't know why they're refraining from like giving these contracts to the individual organization. What we can do. But this demand response activities they have started in Delhi, if you are aware. I think there is some, you can say,
Any person you know, I will discuss with him. Any mobile number or email.
no, so that kind of contacts I don't have as a student, as a researcher, or those. Maybe I'll ask some of my seniors if something they can do. But through the channel, what I knew from this channel, if they have told, like they have not given you permission, then I don't know.
Okay, madam.
Okay. Okay, so I think we'll close the session, or if anyone
So,
has.
ma'am, in which field you are doing PhD?
My PhD is on like this transmission and distribution system coordinated
Transmission.
operation of this. Like, no, these entities have not emerged fully in India. We have a system operator only, NLDC, but for distribution system we have only discoms, like distribution companies. But as you know, this renewables will penetrate demand response and demand side management will come into the picture. It's discoms, their role has to evolve to DSOs. And these kind of DSOs, they are prevalent in the European and American context. And India is also coming, like they are proposing to transform, like what should be the role of this DSO. They are transforming, maybe they, what our intuition is, they will transform the discoms as the role of DSOs. And once you get 24 like for each state will have a distribution system operator. So this coordination has to happen, no? From distribution system operator to the operator who is sitting in the central level, transmission system operator. So how they will communicate, how they will coordinate for the optimal operation of the whole system. So basically, what your role will be in the future is you will act as an aggregator, as I can, if like I am trying to guess. So as an aggregator, there will be after, according to my work, what I'm doing, you will be having two level of markets in the transmission level and in the distribution level. So you come under distribution level as an aggregator in the distribution system. So if you want to like purchase power, so with this also there are certain models. One of the model is that as aggregator you will participate in the distribution level market, where the distribution system operator will be the head, and this through this distribution system operator Let's say if your bid, after satisfying its own need, some amount of bids it is having with the DSO. The DSO will further participate in the transmission level market. This is one of the model. Another model that we are researching is that these aggregators, they will directly, aggregators along with the distribution system operators, all of them will participate in the transmission level market, and then centrally the bids will be cleared. And so this is regarding to the coordination models. We are studying three, four types of variations of these coordination models, and the problems that we'll be facing, that is also different in the context of let's say reactive power in the congestion, scheduling. Then there is state estimation, like each of the transmission studies basically.
Why I think 15 minutes is too short for a bidding, what you say, time. Why it is 15 minutes? Any logic behind that?
15, the greater this the this window, if it will shrink, no, then we'll get a more accurate in our system operation, right? In the US it is for 5 minutes, sir. So
We cannot compare US with India.
in
So
real
now,
time, obviously, the but we are moving towards that, no. So when this dispatch comes in real time, let's say we have a forecast for day ahead, for 24 in our day ahead, the error that it will have, and let's say if I am forecasting for 15 minutes ahead, the error that I will have, that will be that will be very less, no. So we'll be having more accurate dispatch. So lesser the time interval that we are planning for, more accuracy we'll be having, more real time control or operation we'll be having.
so then, ma'am, why it is 2 hours load shedding is there in India?
See, that again comes because you're getting your power through the discoms, right? Right now, India is energy surplus, but again, this peak, that peak demand management we get, no. So these are, we can, theoretically everything is there, but again, many of these discoms, they are all right now in huge loss, because we have government with us, we have politics involved here. So everything is not white. Okay,
Thank you, ma'am.
okay. Thank you, sir. Okay, then I think we'll close the session for this week. Thank you, everyone, and we'll join for the next week.
Thank you, ma'am.
Thank you. You may now leave the call.